A quick question to all of you. Diwali over, Parav. Diwali has 8 more weeks, 8 more months to come. Or 7 more months maybe. So, coming back to, hey Vasundhara. Coming back to our plan. So what did we learn yesterday? That is not a question for Arav. I'm trying to control everybody's emotions. Let's see what is Lakshita's point of view. Lakshita, what did we learn yesterday? Let's see.
I wasn't here yesterday.
You were not there yesterday. How about you, Nihan? Do you remember what did we learn?
They learned about like A minus B and like the rules of that.
So standard polynomials. We learned about polynomials. Yeah, Dikshita. Let's see what do you remember.
We learned about polynomials, multiply, divide, addition, and subtraction.
Okay. All right. Yeah, Advik. Anything interesting that you remember?
We learned polynomials and multiplication, division, the simplification of algebra.
Okay. All right. And yep, Gitesh, what do you remember?
We learned polynomials. Did we learn more like other? Did we learn trinomials, stuff like that too?
See, polynomials is a wider category which caters to everything, every expression which has more than one term. So whether you call it binomial, trinomial, pentanomials, whatever nomials, it has more than one term. Okay,
Learn
now.
Like addition, subtraction of that, simplifying it.
Right. Yep, Arav. What else you can add?
We learned about how it can consist of many types of equations we can use with polynomials, including how we can use them to form new variables, like for instance, A times B could be AB or BA.
Okay. Now, Vasundhara, anything that you remember apart from what the kids have mentioned already? No?
Not really. I just polynomials.
Okay. So your voice is sounding much more firm today, Vasundhara. You always talk when your voice comes very low, and I have to keep on asking you to repeat. But today it's much clearer. Okay. Okay. All right. So Lakshita, you got a basic sense of what did we cover yesterday. And you can probably do a recap of that by going through the video of yesterday's class, which I uploaded, I think yesterday night itself. And today I sent a message. Okay. Now, Myra, any question you have before we move on?
No, sir.
Okay. All right. Arihan, how about you? No questions?
Yeah, no questions.
Okay. So let's go back to practice few problems, because practice makes, earlier people used to say practice makes a man perfect. Now I have changed that. Your thumbs up has to be brought here, because if you keep like this, it will be a thumbs down for no reason on the screen. So what I'm saying is, people used to say practice makes a man perfect. I have redefined that, saying practice makes every kid perfect. So that's why it is important for you guys, and I will keep on insisting on the fact that you guys have to keep practicing whatever we learn in the class. Now let's go to what we learned yesterday and what we want to do a recap of. So we have somebody joined. That is Saranya Kumaran. Are you a new child in the class today? Or it's a known child with a different name? Saranya, can you introduce yourself, beta? Saranya Kumaran, okay, has left. Okay, Pranav also has joined. So let's quickly go to the things that we learned yesterday and do a quick recap. Simple things, these are called standard polynomial theorems or equations, and those are like this. Okay. Saranya Kumaran, can you tell your name, beta?
It's me, Tanu.
Now I want to pull you into the classroom. Okay, no, Tanu, you have been missing in the classroom for some time. See, the whole classroom looks empty. Come over to the classroom, man, sometime. Okay. All right. So basically, coming back to what we had learned yesterday, these are called standard polynomial equations. A plus b whole square equals a square plus 2ab plus b square. Similarly, a minus b whole square equals a square minus 2ab plus b square. A square minus b square equals a plus b into a minus b. And this is what we saw also yesterday, how these formulas are derived. Hey Gautam. Gautam is also not in the classroom today. Okay. Gautam, can you hear me okay?
Yeah.
Okay.
Sorry.
Alright. Yeah. And I would request everybody to keep their videos on because that's the only way I feel like talking to the kids. Otherwise, I'm talking to the screen. So these are the standard polynomial formulas that we saw yesterday, and we also saw how it happens. I'll just do a recap for some of the kids who were not in the class yesterday. If I'm talking about a plus b whole square, let's pick up this one. A plus b into a minus b. Let's say what happens. A plus b into a minus b. What happens is, you can break this down as a times this plus b times this. Or if you take this as a base, you will say this times the whole thing, then this minus this times the whole thing. Any which way is fine. So let's say if I pick this as my base, then I will multiply a with the whole thing, then I will multiply b with the whole thing. So this will break down into a times a minus b, and then I have plus b times a minus b. This is how I can explode this. And now I will break open this bracket also. This one becomes a into a becomes a squared minus a into b becomes ab. Then I have plus b into a becomes ba. B into a or a into b is the same thing. Then plus into minus becomes minus b squared. So here you will see that you have 1 plus ab, 1 minus ab. They kill each other. It becomes a square minus b square. So these are the standard polynomial formulas that we learn, and that we'll keep on using for rest of our journey with math. Okay, this is normal. So yesterday we talked about how do you multiply any polynomial. So polynomial, if you see, polynomial is nothing but any expression which has more than one term. So if I have x squared minus 4x plus 8 as one expression, it has 3 terms, 1 term, 2 term, 3 term. So it's a polynomial. Any expression with more than one term is a polynomial. If I say 8x cubed, is this a polynomial? 8x cubed, is this a polynomial? Question to everybody. No, because it has only one term. Yeah? Now, this is gone. So, if I have another polynomial, let's say 2x minus 8 or 2x minus 15. If somebody says this is my polynomial a and this is my polynomial b, find out the value of a times b. A times b will be nothing but a is this whole thing. So x squared minus 4x plus 8 multiplied by b. This is 2x minus 15. And the same way, you can take this as a base, multiply everything with the whole thing, or you can take this as a base, multiply everything with the whole thing. So if you take this as a base, x squared into 2x minus 15 minus 4x into 2x minus 15 plus 8 into 2x minus 15. That is how you will break it down. Is that clear, Lokshita? Okay. Alright. So everybody is on the same page. So now, in today's class, we are going to do few problems, okay? Which will involve multiplication, division of polynomials, and we'll see whatever we have learned, are we able to apply that? Okay? So let's pick up first problem. And as I keep saying, we will use the concept or our silver bullet called RAN. Read, analyze, and then do it. The first question here is, it says simplify 5x squared plus 8x minus 3 plus 2x squared minus 7x plus 13x. So this is, if you look at it carefully, this is 5x squared plus 8x minus 3. This is one polynomial, and this is my second polynomial, 2x squared minus 7x plus 13x. The question says simplify, meaning you have two polynomials to be added, add them and try to simplify them. Do you guys want to give it a shot? Gautam, are you able to see it clearly? Okay. I'm reading the question one more time. 5x squared plus 8x minus 3 plus 2x squared minus 7x plus 13x. Do this and simplify this. And the second question is same thing. So what I've done is, the same question has two flavors to it. In one situation, you are adding the two polynomials. In the second situation, from the first polynomial, you are subtracting 8 times the second polynomial. So I want you guys to get your hands dirty and solve this in next 5 minutes. Or less. Is everybody trying? Mara, are you trying? Arihan, Vasundhara, Gautam, Dikshita, Gitesh. Thanu? Okay. I'm here. You guys might not be able to see me, but I can see everybody. I just took a chair to sit down. Arav, that extra stunt will not help you solve this problem without mistake. That is not a good recipe for learning math. Oops. And as soon as you guys are done, just raise your hand. Are done? I'm here. I was just sitting on a chair, so that's why you can see me. What is the answer? For the first one, what is the answer for the second one? I want both of them to be solved.
For the first one, I got 7x squared plus 14x minus 13.
Minus 13. 7x squared.
3. Minus 3.
7x squared minus 14x
Plus 14x.
plus 14x minus 3. Okay. How about the second
for
one?
the second one, I got 3x squared plus 28x plus 3.
3x squared
Yeah.
plus
28x.
okay
plus 3.
Okay. How about you, Gautam?
I'm working on the first one right now.
Okay. Anybody else got it?
Is the last in the second set of polynomials is the last number 13x?
Yeah.
Okay.
Yeah, Dikshita.
For the first one, I got 7x squared plus 11x minus 3.
You said 11x
Yeah.
minus 3. Okay. How about the second one?
I'm still working on this.
Yeah, Asundara.
For the first one, I got 7x squared plus 14x minus 3. And for the second one, I got 3x squared plus 2x minus 3.
And I'm assuming that you saw this number 8 here, right? Everybody saw this number 8 is there. 8 is multiplied with this whole thing, right?
I didn't see the 8.
Oh, okay. That could have been the reason why. That's why I'm a little worried whenever I'm seeing this answer, right? 3x squared. That makes me think that you guys probably did not see the number. I'm just reading it for you guys one more time. It's 5x squared plus 8x minus 3 minus 8 times 2x squared minus 7x plus 13x. Yeah, Dikshita.
Can I change my answer to 7x squared plus 14x minus 3?
Sure.
Teacher, I think I made a mistake because I think I didn't saw the 8x because of the light was covering.
So what is your new answer?
I'm still doing it.
So I'll give you guys 2 more minutes, okay? Yeah, Vasundhara. Yeah, Vasundhara.
I got the new answer. I got negative 11x squared minus 40x minus 3.
Like this?
Yeah.
Okay. So, Yadvik.
Sir?
I got the same answer.
Same.
For
Same as whom? So,
I got
just
18x squared plus x minus 15.
I'll come to you, Gautam. Just 1 second. Let me hear what Yadvik was saying. Yadvik, what was your answer?
Same one as negative 11x squared minus 40x minus 3.
Okay, okay.
Yeah.
Yeah, okay. Same for you, Gautam, also?
No, I don't know if this is correct, but I got 18x squared plus x minus 15.
Like this?
Yeah.
Okay. So, Tanu, how about you?
For the first one, I got 7x to the power of 2 plus 14x minus 3.
Okay. How about the second one?
I'm still working on the second one.
Okay. Now, we have few more problems to solve. So, I'll probably go a little fast and I will... Anybody else who has raised hand? Yeah, Vasundhara, you have a different answer or whatever you said is correct?
I forgot to put
Okay.
down the hand.
That's okay. Arihan, what did you get?
For the second one, I completely forgot about the 8. So
Okay.
I'll tell you the first one. I got 7x squared plus 14x minus,
Okay. So now, I want everybody to just stop doing what you're doing so that we can get past this question, okay? And again, there's nothing fancy about it, it's just about doing it carefully. So let's just stay still. Stay still because see what happens, I'm teaching and I see somebody doing this on the screen. And it immediately draws my attention and I get distracted. Don't do that. Yeah, Dikshita, you're saying something? No?
Sorry, sir, I was resting.
Okay. So here, always remember one basic thing that I mentioned yesterday. Whenever we are dealing with polynomials, we only add apples to apples, oranges to oranges, watermelon to watermelon, potatoes with potatoes, tomatoes with tomatoes, x with x. What it means is, we match the power of the variable. If they match, then only I will treat them same. So here, if I am looking at the first one, what are the same things? 5x squared. Okay, so let's first break the bracket open. Somebody is typing, don't do that. So this one, I am just first opening the bracket, 5 squared plus 8x minus 3. And then I am opening this bracket also. It's a plus, so everything remains as is. Minus 7x. See here, minus 7x plus 13x. I can add them together. This together becomes 6x. So that I don't have to worry about it. Here also the same case, I will just combine them and make it 6x. So that I don't have to do extra calculation. Okay. So this is what we have after breaking open the bracket. Now whatever I can add or I can treat as same will be a function of whether they have same power or not. These two have same power. I can add them together or subtract them together. This one has same power. They are similar stuff. Put these together, put these two together. 5x squared plus 2x squared, 7x squared, no problem. 8x plus 6x, 14x, done. And then I have a one orphan child, minus 3, done. So first one has no issues. Now the second one, even if I don't do whatever I did, minus 7x plus 13x. When I have this, I don't want to do a lot of calculation. I don't like doing a lot of calculation either. Though I'm okay getting my hands dirty, like what you can see here. I'm taking this one. Let's open this bracket first. What do I have? 5x squared plus 8x minus 3. Nothing to worry as it comes down. Now I have minus and I have an 8. So this has to be multiplied with every term to break this bracket open. Now another thing that I notice here is I have minus 7x plus 13x. So let me hold this thing for a little bit. 2x squared, and then this minus 7x plus 13x becomes plus 6x. I'll do this calculation first in the bracket before I break it open. Now this is 5x squared plus 8x minus 3. Now let's open this guy. So minus 8 times this, minus 8 times this. Minus 8 times this becomes minus 8 times 2 is 16 x squared. Minus 8 times this becomes plus, minus into plus is minus, and 8 times 6 is 48 x. Now these two are from the same family, and this are from the same family. I put a double line here, single line here. Now 5x squared minus 16x squared. I have a negative 11x squared. This and this are done. What is the next one? 8x minus 48x, which makes it minus 40x. And then this orphan child. So this is the answer. If any of you missed this one, it was probably because of an oversight. That's the only reason. Otherwise, this cannot go wrong. And that is why I was pushing you guys to give the answer quickly, because this is simpler. I mean, this is not a time-taking math for sure. If you guys want to spend 30 seconds to review what you did and where your answer is different from what we have on the board, it is worth doing. Otherwise, I'll move on to the next question. Shall we? Okay, let's move to the next question. So here also, if you see, right, one thing you will find me as a teacher is always consistent with the storytelling part. Meaning, when I'm doing the math, you will see that there is a story that I'm stitching. I'm going step by step. And that I would prescribe to all of you, because that will help you make sure that you keep a track of how your computation is happening. Okay? Let's go to the next question. The next question is, six x squared plus 9x, multiply this with x squared minus 4x plus 4. And I would not give you guys more than 3-4 minutes. I'm repeating the question. 6x squared plus 9x times x squared minus 4x plus 4. So I would want everybody to give it a shot. Hiranya, Deekshita, Gitesh, Lakshita, Pranav, everybody, okay? Myra. Yep. Do this quickly, and the first person who has to answer me will be Myra. Myra must be thinking she is trapped, but she still has to answer it. So Myra, Hiranya, yep, Myra.
I'm still solving.
Yeah, no, I'm saying the first person who has to answer. So you could be the first person whom I'll be asking is going to be you. Let's see who can solve it real quick. Yadav.
I'm done.
Read your answer.
7x.
One more time.
1 second. 7x squared plus 9x squared plus 10x squared minus 36 plus negative 24x squared
Plus
negative 24x squared plus 36x plus
plus.
yeah.
Now one thing, Arab, you have rushed to give me the answer, and I appreciate you for the speed. But one thing that is very evident is you have not completed some of the transactions here. Like if you have 7x squared plus 9x squared plus 10x squared minus 24x squared, why do I need to get so many x squares from you? Why can't you combine them all and give me one x squared? You get what I'm saying? So, see, my message to everybody is very simple. If you are quick, that is awesome. I love that. But I would want you to spend 1 more minute to use the time for review and then give me a perfect answer. And not only to me, okay, I'm irrelevant. It will actually help you in your actual exams, okay? Do that. Yep, Advait. So, finalize your answer, Araf. I'll come back to you, okay?
I got 6x to the 4th power
Okay.
minus 15x cubed
Okay.
minus 12x squared
Okay.
minus, it's minus.
Mm-hmm.
No, it's like minus in between, yeah.
Minus 12x
Then
squared.
Plus 36x.
Okay. That's it? Okay. Yeah, Gautam.
I got 6x to the power of 4 minus 15x to the power of 3 minus 12x plus 12x squared plus, minus 36x. So I got the same as him.
So this is minus 36x or plus 36x?
No. Yeah, it's minus. It's minus 36x.
Okay, so Gautam got minus 36x and Advik got plus 36x. Okay? Yep.
I got the same answer, but I got plus 36.
So Advik and Arab got plus 36x. Gautam got minus 36x.
Yeah, it's plus 36x.
Okay, so everybody got plus 36x. Okay, wonderful.
Yeah, it's plus.
So now see, we don't all have to commit the same mistakes and learn from it. What is that we are observing here? I would want you guys, when you guys are growing up, be more watchful of what you observe or see in your surrounding. So for all of you, right, look at what Arab did and what changed for Arab. Arab did that question in a hurry and he got a different answer. When he did a review of his own work, he found a different answer. I am not still saying whether his answer is correct or not, but review makes a huge difference. So make sure that we all get into the habit of review of our own work. Same thing for Gautam also, right? Gautam got a different answer, then he reviewed and he realized, okay, there was one small thing that he was overseeing, correct? So without putting anybody on the spot, my message to you all is that whatever you do, never assume it to be perfect, because none of us are perfect. At least I'm not, right? And everybody, we should get into the habit of reviewing our own work. Doing the work takes 10 minutes, reviewing might take 1 minute. It is worth spending the time. Yes, Dikshita, you were saying something. You got the answer?
Yes, sir. I got the same one.
Same answer. Bad news.
Yes.
How about you, Myra?
Yeah, I got the same answer. I'm trying to simplify it right now.
What will you simplify further?
My answer?
Uh-huh. No, I'm saying you got the same answer. You're saying I'm trying to simplify it now. I'm just curious what you're simplifying or how you're approaching to simplify it.
I'm trying to find numbers that are like x squared. I'm trying to like add them together and like find a common number.
There might not be any opportunity. There is one opportunity that is there for sure, and I was hoping somebody will talk about that, but we'll see. Yeah, Nihan.
I got the same answer.
Okay. So who all has not come back to me? Hiranya, Lokshita, did you guys finish it or are you still doing it? Yes, Lokshita.
I got the same answer.
Okay. Hiranya also got the same answer. So Hiranya got the same issue with the mic, is it? Your sound doesn't come through? Time to buy a new laptop then. Like me. I also have one laptop that's been there, not as old as me, but pretty old actually. So I need to replace that too. Okay. Yeah, Thanu.
Same answer.
Same answer. Okay. So now, I have no problem getting my hands dirty, so I'm getting my hands dirty, and there is one clue that I'm alluding to. Okay, let's look at this. The thing is, we have to multiply these polynomials and try looking for opportunity to simplify it. That's the question. So here, same thing. If you take this as a base, multiply each and every term with the base. So it will be 6x squared times x squared minus 4x plus 4. Plus 9x times x squared minus 4x plus 4. That is the deal. So now let's break this bracket open. 6x squared into x squared, that gives me 6x to the power 4. This into this becomes 6 into 4 minus 24. X squared into x becomes x cubed. Then I go to this guy. 6 times 4 is 24 x squared. This one is done. Then I go to this guy. 9x into x squared, so 9x cubed. 9x into minus 4x, so 9 to 4 minus 36. X into x gives me x squared. And then this one, so 9 times 4 is 36x. Now let's find out apples and apples, bananas and bananas, guavas and guavas together. This, let's say x power 4 is apple. Do we have any other apple here? No. So this apple remains here. Then let's look at the power 3 items. So this, let's say this is banana. So 24, negative 24 bananas and then plus 9 bananas. So we have minus 24 plus 9. That makes it minus 15 bananas. Okay. Now let's look at the oranges. 24 oranges here. X square I'm calling as oranges. So 24 oranges here and 36 oranges here. This is negative, this is positive. So this becomes minus 12 oranges. What we are left with? 36x. This guy is pretty much, yep. Now, you guys can verify if this is matching with your answer or not. One thing, there's one more thing that you have to look at here. If you look at it carefully, every term has x common. Every term has x common. Here you have 1 power x, power 1. Here you have power 2, you have power 3, you have power 4. So if you want to look at it, you can also say, I will take x common, and then this becomes 6x cubed minus 15x squared minus 12x plus 36. That would have been a more simplified version. Like when Myra was saying that I'm looking at simplifying it, I thought that probably she is looking at this opportunity to simplify it. Okay. Now, so this was on the multiplication side of it, and trust me, we are not learning anything new. We are just practicing more problems. And again, as I said, if you look at what I have done, I have just written a story here. I have gone step by step. This is my one polynomial will multiply by the one. How do I break it open? Every term of the one polynomial gets multiplied with the second polynomial. Every term of the polynomial gets multiplied with the second term of the second polynomial. And then we are breaking open this bracket. And this is what we got. Alright, let's look at one last problem, and then we will go to something interesting. Let's leave this. I'm not finding any interesting problem right now. Okay. Now, let's talk about something called identifying quadratic patterns. How do you identify quadratic patterns? Now, what do you mean by that? First of all, what is quadratic expression? Everybody remembers, right? Nobody has any doubt about it. If I say quadratic expression, that means an expression like this is a quadratic expression. Why? Because the maximum power to the variable is 2. Yeah? Now I'm saying identifying quadratic patterns. How do you identify different quadratic patterns? What is meant by that? Now keep one thumb rule in your mind, that whenever we are solving a problem, whenever we are dealing with a problem, the goal is to simplify it. The goal is to simplify it for the sake of solving a problem. Okay. Let's say if I say this, let me give you guys one quick problem and you know how to solve it. Okay. If I say solve this, you get Adam, can you put your pencil down? What did I say? You have been in my class for more than a year now. And what I have been telling you is, doing is the last thing. Can I repeat it anymore? Nihan, don't try solving the problem better, please. Doing is the last thing. If you don't, okay, so I know you have the answer, Gautam, but hold it for a little bit, okay? Because let's put our head together. Solving is the last thing. And I will keep on insisting on that. Because You got a question? You put a pen. Hold it. Take a deep breath. Recall all the gods you believe in before you try solving the problem. Okay? Why? Because if you not put your thoughts around things, if you don't read the question again, you don't put your analysis together. I'm not saying that you guys are as slow as I am. I know you guys are much faster than me. But then, still, there is no compromise on your ability to analyze the problem, okay? Now, here, why I was giving this problem in the first place, why I stopped everybody from giving the answer to me. Because I was saying that if I have a problem like this, ultimately, what is my goal? I'm trying to break this into something like, let's say A into B. Okay? I'm trying to break this like A into B. Something into something. And then see if I have a or a B here. If I get that, if I can break this thing into A into B and I have either A or B in the denominator, then I can do tic-tac. If I have a B, I will do tic-tac-toe with this. This will become my answer. If I have an A in the denominator, I will do tic-tac-toe with this guy. B becomes my answer. So, whenever you are talking about a quadratic expression, your goal is to find out the quadratic pattern. What kind of quadratic equation you are dealing with, and then can you convert that to factored form, split that into two parts, something into something, and then see if you can simplify it. Now I'll come to the problem. So, tell me, Gautam, what was your answer for this guy?
It's x minus 5.
X minus 5. What? How about you, Arav?
Same.
Same. Now, whether it's x minus 5 or x plus 5 or anything else, I'm least concerned right now. Because my message to you all with respect to the approach is this. If I have a quadratic equation, can I convert this into something form? And that is where I recall these fundamental polynomial expressions that we have learned in the class yesterday or even before. These are the fundamental polynomial expressions we have learned, or formulas we have learned, or standard forms, whatever you call it. If I can relate any of my quadratic equation with this, let's say if I see whatever I have, if I can convert it to this form, if I see it mapping to this one, it becomes a plus b whole square. So then I can write this as something square. And if I have, so that's what Gautam and Arav did. This is okay, fine. This is x squared minus 10x into plus 25. Is it like x squared minus 10x? I can write this as 2 into 5x plus 25 by x minus 5. Now look at this. A minus, see, I have x squared minus something plus this. This is certainly not a plus b whole square. This might be relating with this guy. A minus b whole square. Now, a minus b whole square gives me a squared minus 2ab plus b squared. Is this b squared? If this is 5 is by b, this is b squared. So this is x squared minus 2 into x into 5 plus 5 squared. So that would mean that this became, this one is a minus b whole square formula. So I will say this is x minus 5 squared by x minus 5. What else do we need? That is how you got x minus 5. Yes, Myra?
I can't see your screen. I can hear you, but I can't see your screen.
You'll have to disconnect and join back again. That's the only way.
Okay.
Yeah. So, here, can you see my screen now, Myra?
Yeah.
And I have even a better solution. If it doesn't work anymore, just walk downstairs come to the garage. You'll be able to see me and the screen much better. Arav, was that a feedback for you? Are you Myra? No. Okay. So coming back to this one. This is why it becomes very important for us to have these rules or theorems or formula, whatever you call it, by heart, so that we can relate it with any of the existing, any of the quadratic equation if possible, and then try solving it. Now let's try looking at solving one more problem. But before we do that, there's some more thumb rule that we need to know. If I have an expression like x squared minus 2x plus 8, and if I have is there any difference between these two guys? My first expression is x squared minus 2x plus 8. My second expression is 4 into x squared minus 2x plus 8. Is there a difference between the two? Okay. What is the difference? Arav, I will not come to you. I will give you time to think. No, I will not let you commit the same mistake. Think and then I will come back to you. Take 2 minutes. I will come back to you. Yeah, Dikshita, tell me.
Is the top one like we're not distributing, and the bottom one like we're distributing to like each like variable or number?
What was my question? My question was, is there a difference between this expression and this expression? Okay, let's see what Gautam has to say.
Yeah, there is a difference because the second expression is multiplied by 4, but the first one is multiplied by 1.
Okay. How about you, Gitesh?
I was going to say the same thing.
Okay. Arihan?
I feel like this is a trick question and you're just asking, is it yes or no? So yes, there is a difference.
Okay. Now I got the answer. Arav, yeah, tell me.
There's a difference.
There is a difference. There is a visual difference, right? Now, is there a difference? Yes, Pranav.
No, sir.
There is no difference. How about others? Yeah.
No, because
No difference? Yeah. A flying balloon is not the answer.
Amen. There is no difference.
There is a difference. Okay, Lakshita, what is your point of view? Lakshita, go ahead.
There's no difference.
Yeah. So there is no difference when it comes to equation. Yeah, Gautam.
I think there is a difference because if you were to solve for x, you would when you distribute. When you move the 8, when you move the 8 to the 0, it would be the top equation would be x squared minus 2x plus 8, but the bottom one would not be the same. It would be different. So if we were to solve for x, it would be different.
Okay, let me put it differently. Okay, I have heard. Okay, stop dancing. When I'm looking at you guys, I'm paying my 100% attention. Okay, so when you do this, my attention gets diverted. Yadvik.
Difference because they both equal 0.
Yeah. So what I'm trying to say here is that when you're dealing with an equation, when you multiply an equation with any number, you're not changing anything actually. You're not changing anything because, see, to your point, Gautam, you said that if I'm multiplying by 4, let's say I'm multiplying by 2, even simpler. Here, x squared minus 2x equal to minus 8, okay? Now, in this case, what happens? I have 2x squared minus 4x plus 16 equal to 0. If I move this guy, I'm not moving 8, I'm moving it to 16. So, multiplying any equation with any number is not changing it. It is just making an equivalent of this. Yeah? Got it? It is just an equivalent of that. It's like you say 1 by 2 equal to 2 by 4. These are equivalent fractions. So these are equivalent equations. Even if you try plotting it on a coordinate plane, you'll plot the same thing. This equation and this equation will plot the same line. Yeah? Similarly, it will help you with the expression also. In case of expression, I would certainly not say that x square minus 4x plus 7 is same as 2 into x square minus 4x plus 7. I would not say that. But this is, I mean, these two are the same ratio. I mean, basically, I would not say ratio. You just multiply it here. And we can use this for deriving factors, basically. So it's like, if I have, let's say, let's talk about this. If I have 4x square minus 16x plus 28 divided by x square minus 4x plus 7. Obviously, you see that, okay, I have 4 common in all of them. If I take 4 out, it becomes x square minus 4x plus 7. And in the denominator, I have x square minus 4x plus 7. So I can do tic-tac-toe like this and my answer is 4. So in case of expression, it will just help you factorize it. In case of equation, if you multiply any equation with any number or divide any equation with any number, you are not changing anything. Okay? Is that part clear to everybody? Yeah?
Yes.
Now let me bother you guys a little bit. Let's say I have 7x squared Okay. I'm asking you guys to divide this polynomial with this polynomial. Out of hold your pencil. So I'm saying 3x squared minus 42x plus 147 divided by x squared minus 10x plus 21. This is the problem that is to be solved. Don't try doing it, otherwise this comes at the end. If you are using your pencil for noting down the question, that is still understood. But this problem you can solve in a minute. If you think properly, you might not be able to solve it in 30 minutes if you don't think. So I'm reading this question one more time. 3x squared minus 42x plus 147 divided by x squared minus 10x plus 21. Do this division and this question is not coming from any notebook. I just made it up. But this should be a legitimate question. This is a legitimate question. Let's see how you guys are approaching this one. And I'm here. I'm just watching you guys. Let me know as soon as you guys are ready. And it's almost time. So this is the last problem for today. But yeah, we'll spend whatever time it takes. Yeah, Dikshita.
I got 3x squared plus 42x plus 7.
3x squared plus 42x plus 7.
Yes, sir.
Okay. And okay. Anybody else being close to solving it? Arihan, Nihan, Sanvita, Hiranya, Lakshita. Now recall Puspa. Arav, this is for you. See, Puspa helps. So you always stop halfway through. I'm saying Puspa completes the complete semicircle. So try that. Semicircle, yeah. Okay, stop that now. Focus on what you're doing. And Dikshita, I would suggest you review what you did. You might find an opportunity.
I simplified it, and I tell you the simplified version.
Any version is okay. Yeah, tell me.
The simplified version is 3 parentheses x minus 7 over x minus 3.
Okay. How about you, Vasundhara?
I was about to say the same thing.
No worries. There's no race. If you both got the right answer, there's nothing to worry. But I am still not sure if it's the right answer or not. I will do it and get it confirmed. Yes, Arav.
I got 3x minus 21 divided by x minus 3. And it's kind of like the same thing, but I used the full equation. So, yeah.
You use what?
I used the full equation instead of simplifying it, but I did the same thing.
3x minus 21. That's what you're saying. So there is no bracket here, basically. The same thing. I mean, it doesn't hurt. So now, okay. Yes, Pranav.
I got 3. 3x minus 7 over x minus 3.
Okay. So that is as in 3x minus 7 like this divided by x minus 3, correct?
Yes, sir.
Okay. So now let me give it a shot and just to verify if you guys got the same answer or not, or if you are all solving in the right way or not. So first thing first, whenever you look at this kind of a thing, we know formulas like a plus b whole square, a minus b whole square, a square minus b square. We don't know something with a multiple in the beginning. There is no formula that we are aware of. I mean, there is no standard straight formula. So as soon as I see this guy looks innocent and cute. I don't have to worry about it. This guy looks a little complicated. So first thing that comes to my mind is, can I take 3 out? If I take 3 out here, is 3 common in all the terms? 3 is fine, 14 3 are 42. and this is 150 by 3 is 50. So this is probably 49. 49 times 3. Okay. So let's take 3 out. Then this becomes x squared minus 14x plus 49 divided by x squared minus 10x plus 21. Let's take care of the numerator, then we'll come to this guy. Now here, this is a squared minus 2ab. 14 I can write as 2 into 7. So this is my b, this is my a. And this is b squared. 7 squared is 49. Wonderful. This is a perfect square scenario. So this becomes 3 into x minus 7 squared. And here what do we have? X squared minus 10x plus 21. Now here what we know is, okay, I have 10x. Can I break it into two parts? I will say 3 into x minus 7 squared, and here if I break this, x squared minus 7x and minus 3x. This also makes it 10x, and then I have 21 here. Only word of caution here would be that these two numbers multiplied should give me this. And I'll tell you, there is a concept behind that, okay? Whenever you are breaking up this thing and trying to factorize it, convert this into a factor form, this is what you would want to check. Right now I'm just doing it randomly. 10 minus 10x, I am breaking to minus 7x minus 3x. Now if I keep these two things together, only thing I have to keep in mind is the coefficient of x by splitting it should give me this one. 7 minus 7 to minus 3 should give me 21. That is the case. Wonderful. I cannot break this as minus 8x minus 2x. That will not work for me, okay? It will not help me factorize it. There is a concept behind that. So I'll explain that to you guys in next class. Here, what it became is, if I say 7x and 3x, I will take these two together. What it becomes? 3 into x minus 7 squared divided by, here x squared minus 7x. I have x common. It becomes x minus 7. And here if I take minus 3 common, it becomes x minus 7 again. See, it is a reverse of what we have learned with respect to multiplying polynomials. Same thing is multiplied with x and minus 3. That means I can convert this into x minus 7 squared divided by x minus 3 into x minus 7. I just did reverse of what we have been doing, right? When it comes to multiplying polynomials. X minus 7 is common in both of them, so I took it out. If you have to again exclude it, you'll say x into this minus 3 into this. Same thing, I just did reverse of that. Now what did I get? X minus 7 squared here, x minus 7 to x minus 3 here. That is how you can write this as x minus 7 into x minus 7. You will do tic-tac-toe of these two, and that's how you guys got this answer. Correct? Yes, Adrik.
Like in the beginning, how did you what happened to the 147?
So as soon as I saw 3 here, this also 3 is a multiple of 3, this also is a multiple of 3. I took 3 common and I converted this into a factor form. When I took 3 common, this 3x squared became x squared, 42x became 14x, and 147 by 3 became 49. Yeah? Did everybody understand this? So now I would tell you guys one thing, and then I'll let you guys go. Whenever you have to factorize a quadratic equation, is everybody with me so far? Whenever you have to factorize a quadratic equation, as I said in the beginning, whenever we are dealing with this, ultimately we are trying to break this into something into x minus something into x minus something, or be it plus or minus, whatever. try to convert this into something form. Okay, that's our goal. So here, first, any quadratic equation that you have to look at whether you are able to convert this into standard forms or not. Is it relating to any of these forms or not? Our second approach is, if this we are not able to directly relate, what you will do is look at this guy and look at this guy. Multiply them together. So multiply the coefficient of x squared and the constant here, multiply these two. And then find out the factors so that they add up to become b. So multiply these two, whatever you got. Let's say this was x squared plus 16x minus plus 8. Multiply a and c, 1 into 8. Now what you have to do is, this 8 that you got, see what are the factors. 1 into 8, 2 into 4. Look at which one you can add to get this. That is the formula, that's the method. But I know this is new, so you will get stressed out. This will be more fun when we try doing that in the next class, okay? Just learning or hearing the theory makes it complicated. When you do it, you will see a lot of fun associated with this one, okay? So with that being said, simple takeaway is, whenever you're talking about multiplying or dividing polynomials, your goal is to break them into smaller parts. That is our goal as well. When I'm dealing with math, our goal is to simplify them, break them into smaller pieces so that I can deal with them separately. So that is our goal here as well. Okay? Alright, that being said, I'll let you guys go. Enjoy, have fun. See you guys next Saturday. Okay?
Bye, sir.
Bye bye. Bye bye. Take care.